Good morning, students. Good morning, students. So now in today's class, we have to discuss with that classification advanced methods. So in the classification advanced methods, already up to now, what are the classes we have to complete in previous. Those all are basic concepts of the classification. Now in today's class, we have to discuss with that classification advanced methods. So in these methods, mainly we have to concentrate on Bayesian belief networks and back propagation, support vector machines, classification using frequent patterns, lazy learners, instance Bayesian methods. These all methods you have to discuss in this classification. First one you have to discuss with that Bayesian belief networks. In the Bayesian belief networks, mainly you have to concentrate on probabilistic graphical models, which unlike the Navy Bayesian classifiers, allow the representation of dependencies among subsets of attributes. So here in the Bayesian belief networks, Bayesian classifiers allows the representation of dependence among subsets of the attributes. Bayesian belief networks can be used for classification. Generally, here you can represent the subgroup and the concepts and mechanisms. So here in the concepts and mechanisms, mainly we have to discuss what is the Navy Bayesian classifier, makes the assumption of the class conditional independence, that is, given the class label of a tuple, the values of the attributes are assumed to be conditionally independent of one another. For example, here you have to see the simple Bayesian belief networks. The diagram which shows Bayesian belief network. For the A represents that is the family history, smoker, lung cancer, emphysema, positive X-ray, dyspnea. These are the attributes you have in the simple Bayesian belief network. The proposed causal model represents the represented by the directed acyclic graph. This is regarding to this simple Bayesian belief network, and the second table represents the conditional probability table for the values of the variable lung cancer. That is the LC showing each possible combination of the values of its parent nodes. Family history and this smokers, these all you have to represent in the table. FH represents the family history, S represents the smoker, and LC represents the lung cancer or getting or not. These are the information you have to represent it in the concepts and mechanisms of the simple Bayesian belief network. In the simple Bayesian belief network, specify the joint conditional probability distributions. They allow the class conditional independencies to be defined between the subsets of variables. They provide a graphical model of causal relationship on which learning can be performed. So drawing the Bayesian belief networks can be used for classification. The Bayesian belief networks is also known as belief networks or Bayesian networks or probabilistic networks. Anyway, you have to call. So belief networks or Bayesian networks or probabilistic networks. So a belief network is simply mainly we have the two components. One is related to the directed acyclic graph, and second one is the conditional probability tables. So in this diagram, it shows these two components. Belief network defined two components. One is the directed acyclic graph, and second one is a set of conditional probability tables. So A represents the directed acyclic graph, B represents the conditional probability tables. So each node in the directed acyclic graph represents a random variable. The variable may be discrete or continuous value. They may correspond to actual attributes given the data or to hidden variables believed to form a relationship. Y is the parent. If the arc is drawn from the node Y to node Z, then Y is the parent, immediate predecessor of Z. Z is the descendant. This diagram shows that is a simple Bayesian belief network with a directed acyclic graph and conditional probability table. Okay, this is a simple belief network. This diagram shows in that diagram it shows simple belief network. For example, you have to consider different people, that is the Russell, Bender, Kolar, and Kanajwana. So these are the generally 6 billion variables they have to use. And ours know the representation of casual knowledge between that people. So a belief network has one conditional probability table, that is the CPT. So the table represents the CPT, conditional probability table. In each for each variable, the CPT of variable Y specify the conditional distribution P of Y subset of that is simply can be represented as parents y, where parents y is the parents of y. Uh, uh, second table represents the CPT, conditional probability table. Variable lung cancer, the conditional probability of each known the value of lung cancer in given each possible combinations of values. So here, by using this Bayesian classical network, Bayesian belief networks, generally most of the medical diagnosis of a uh, uh, particular disease, you can analyze with this Bayesian belief networks in data mining. So this is the classification advanced method you have to use to analyze the data of the whatever the previous data you have. In that data we have to analyze, and finally we can find out the conditional probable table. For example, here we have to see, for instance, for the upper leftmost and bottom right is respectively, you see that P of lung cancer equal to S, I say. Then family history is also S, and smoker is also S. So that is, you have to represent it as probability you are getting 0.8. If the probability of lung cancer is no, family history is no, smoker is no, that is the getting the probability 0.9. So this is, you have to represent it as simple Bayesian training on Bayesian belief networks. Generally here the maxima is the done following the gradient of the values, the problem simplifier with the network topology and initialized. An algorithm proceeds as follows. First one is the here you have to use the compute the gradients, first process, and the second one, first process is the compute the gradients. You have to using the formula rho of ln of pw of d, rho of w of ijk, d equal to 1, the summation of 1 to d, p of y of I equal to y of ij, comma u of I equal to u of ik, probability of xt by w of ijk. So that is the compute the gradients of values, that is ijk, by using this formula. So next, to compute the gradients of the particular Bayesian belief network, then take the small step in the direction of the gradients, and then renormalize the weights. These are the three steps you must be followed whenever you have to define the network topology. Whenever you are using a particular algorithm, you have to follow. First one is to compute the gradients, take a small step in the direction of the gradient, and third one is the renormalize the weights. Okay. This is regarding to that Bayesian belief networks. Classification by propagation. The next concept is the classification by propagation. Uh, back propagation is a network, a neural network learning algorithm. You have to mainly we have to use this classification by back propagation. Started by the psychologist and neurobiologist to develop and test the computational analogies of neurons. A neural network is a set of connected input-output units where each of the connection has weight associated with it. So here, the classification by propagation, back propagation generally you have to call it as it is a neural network learning algorithm, neural network learning algorithm. The neural networks field was originally coined by the psychologists and neurobiologists. So mainly these neural networks you have used by the doctors regarding to the psychologists and neurobiologists. They have to use this neural network. So in that cases, this classification block population method you have to use. A neural network is a set of connected input or output units in which each connection has weight associated with it. During the learning phase, the network learns by adjusting the weights so as to be able to predict the correct class label of input tuples. Neural networks learning is also referred to as connectionist learning due to connections between units. Neural networks involve long training times are therefore most suitable for the applications where this is feasible. They require a number of parameters that are typically best determined empirical, such as the network topology or structure. Neural networks have been criticized for their pure interoperability. For example, we have to consider it is difficult for the humans to interpret the symbolic meaning of behind the learning and of hidden units in the network. So generally, humans could not understand what's going on inside the body, but only you people, or that is the psychologist people and the neurobiologists, they can understand by applying various backpropagation methods and classification. So easily I can identify and analyze the data. We can observe what's going on inside the body. So that is simply you can say that classification by population. See here, generally neural networks simply you can use the learning algorithm. A neural network, a set of connected input-output units, where each connection has the weight associated with it. During the learning phase, the network learns by adjusting the weights so as to be able to predict the correct class label of the input tuples, and also referred to as connectionist learning due to the connections between the units. What are the advantages of neural networks? So here you have to include their high tolerance of noisy data as well as their ability to classify patterns on which they have not been trained. That is simply you can say that natural networks they can be used when you have little knowledge of the relationship between the attributes and classes. They are well suited for the continuous value input and outputs, unlike most decision tree algorithms. Okay, here neural network algorithms are inherently parallel. Parallelization techniques can be used to speed up the computation process. So most of the these neural networks algorithms mainly are inherently parallel. So why? Because parallelization techniques already it is speed up the process.
ఇప్పుడే పెట్టారా అక్కడ
So this is regarding to the classification by propagation. The most popular neural network algorithm is backpropagation. Backpropagation is a very key important role nowadays. Why we have to analyze the particular disease with this back propagation, which gained the repute in 1980s. Mainly you have to implemented this one, and this back propagation mainly we have to use multi-layer feed forward neural networks. We have to use the propagation back propagation algorithm performs learning on a multi-layer feed forward neural networks. It is iteratively learns a set of weights for the prediction of the class label of suppose multi-layer feed forward neural networks consists of an input layer, one or more hidden layers, and the output layer. Example, multi-layer forward network is shown the figure like input layer, hidden layers, and output layers. Generally, some x1 to xn, that is all are simply number of input values, that is the x1 to x of n, and hidden values a little bit less values compared to input values. Finally, the output layer has the only two values only. That is the O1, that is the O1 to OK. That is the multi-feed forward neural networks. Each layer is made up of units. The inputs to the network is corresponding to the attributes measured for each training tuple. The inputs are fed simultaneously into the units making up the input layer. These inputs pass through the input layer are then weighted, fed simultaneously to the second layer of the neuron-like units known as hidden layer. The outputs of the hidden layer units can be input to another hidden layer and so on. So ఇక్కడ జనరల్ గా మనం త్రీ లేయర్స్ పెడతాం. One is the input layer, second one is the hidden layers, and third one is the output layers. So that type of network is multi-layer fed neural networks. Defining a neural network topology. How can I design how I can design a neural network topology? Before training can begin, the user must decide on the network topology by specifying the number of units in the input layer, the number of hidden layers, the number of units in each hidden layer, and the number of units in the output layer. So here the propagation, back propagation work, how it works. Once we have to see, back propagation lands by iteratively processing a data set of training tuples. So training data set we have to consider here. Comparing the network's prediction for the each tuple with the actual known target value. The target value may be known class label of the training tuple or continuous value. The target value may be known class table of training tuple or continuous value. For each training tuple, the weights are modified so as to minimize the mean square error between the network's prediction and the actual target value. Uh, these modifications are made in the backwards direction. So through each hidden layer down the first hidden layer. That is the propagation. The back propagation algorithm, it is a trained neural networks. We have to give the output. Inputs as taken as a data set consists of training tuples and their associated target values. Learning rate and network multi-feed forward network. So you have to take the input and you get the output as trained neural network. This is the back propagation. Iteratively process of a set of training tuples compare the network prediction with the actual known target value. For each training tuple, the weights are modified to minimize the mean square error between the networks and prediction and actual target value. Modifications made in a backwards direction from the output layer through each hidden layer down is the first hidden layer, hence back propagation. Steps, what are the steps you have to follow? Initialize the weights to small random numbers associated with the biases. Propagate the inputs forward by applying activation function. Back propagate the error by updating weights and bases, terminating conditions while error is very small. So this is regarding to the back propagation and its error. You can find out back propagate error. Error of j equal to O of j minus O of j of 1 minus oj into t of j minus O of j. Oj is the actual output unit, unit j. The tj is known as target value given the training tuple. O of j 1 minus oj is the derivative of the logistic function. So finally, you can get the back propagate the errors. So this is regarding to this back propagation. So here, whenever you have to discuss with that back propagation, is the sensitivity analysis we can do with that, and the so next one support vector machines. The support vector machines mainly you have to. It is a method for the classification of both linear and nonlinear data. SVM, that is the support vector machines, is an algorithm that works as follows. It uses the nonlinear mapping to transform the original training data into the higher dimension. Within this new dimension, it searches for the linear optimal separating hyperplane with the appropriate nonlinear mapping to suppose sufficiently high dimension. Data from two classes can always be separated by the hyperline. So finally, you can get the support vector machine finds his hyperline using support vectors, and the margins supports vectors and margins, or simply call it as support vectors. The case of linearly separable, we will continue in next class. That is the support vector machines in detail regarding to the number of cases, two-dimensional, three-dimensional, and the data how we can define along with the cases, linearly, non-linear, inseparable, inseparable. These all concepts we have to discuss in this class.